Hello everyone, and thank you for signing up for this TÜV SÜD webinar on BIM management and with model checks for automated code compliance. Before we start the presentation, I will go through some basic housekeeping to keep this session as smooth as possible. Firstly, we have participants calling in from various locations, hence you're automatically placed on mute to reduce background noise. Secondly, this is a 1 hour and 30-minute session, which includes some time for questions and answers. At any time during this session, you can send in your questions directly to the panelists through the Q&A function, and we will address these questions at the end. We will also be having some interesting polling questions during the session, so please join us in the polling. Lastly, this session will be recorded and made available on demand later. Our speakers for today are Mr. Tobias Schmidt and Ms. Elise Mandit. Tobias is the Global Manager for Digital Lifecycle Solutions. He has been a BIM Director since 2004, working on various international projects for medium and large organizations, including government-related ones. Prior to his current position in TÜV SÜD, he was the head of Global BIM Center of Competence, which covered BIM topics such as common data environments, computer-aided facility management, and other digital built environment processes. Elise is the BIM advisor in TÜV SÜD, and she specializes in hands-on BIM model quality control, software application, and BIM management. She also focuses on driving owners' decisions from the start of the project to create technical and commercial success. Besides being a BIM advisor, Elise also is a registered architect in Germany and has succeeded in BIM project management internationally, including USA, Germany, and Singapore. With that, I'll pass the floor over to Tobias.
Thanks a lot, and good afternoon, everybody, to Singapore. And I've seen that we have a couple of guests also from India and Malaysia, Philippines, and so on. So a warm welcome from our side. And we would like to take on a very exciting journey to this model checking item today. So I would like to start with this map that should indicate that we have IFC experience across the globe. That's very important because the Asian setup on IFC is a bit different. So we see really ourselves in a position to be a bridge function between Latin America, Europe, and Asia as well. And as you can see, everything we're talking about today, we collected or we gained through project execution from government and public sector, from industry sector, and from the classical REIT business. That's interesting as well because the building itself, they are really different. So we would take you on a journey about this IFC model checks for all these different topics. Interestingly, so we are not academic guys. I think that's very important for you to know. All of our knowledge we gain, we really gain in practice projects. And TÜV SÜD has a division called Real Estate and Infrastructure. Most of you, I think, know us already. And we're really focusing on technical and delivery excellence. So our goal is really to achieve an optimal building life cycle and to take with us all stakeholders like consultants, contractors, and so on, and for sure the owners and operators. And this chart on the left side indicates that for us, the design phase is, how to say, the mother of a building life cycle. So we are moving into this early stage, all operational and construction know-how. And that is why model checks in this position, like you see this brick number 1 design, you see ISO 19650, BIM audits and management and model checks. They are really essential to, how to say, deep dive into early phases, into all these essential things like BIM to CAFM, design for maintainability, and so on. So that's why model checks are a really essential pillar for us to, how to say, across the building life cycle itself. TÜV SÜD implemented BIM in 2015, and a couple of us already know our local teams in Singapore and in India. By fact, in total, our group joined today 280 project consultants. And the interesting thing is we could really do a lot of R&D, but a lot of project delivery as well for a couple of the 56,000 buildings. And like I say before, our position is really to be the man in the middle. It means that we see ourselves as a knowledge gateway to all stakeholders that are involved in a single project. All right. And this slide, again, highlights that model checks, or how we translated the digital quality and risk management for IFCC projects, are not a single matter just for design phase, but they're really going through design, bid, build, operation, renovation, and so on. So all this quality checks, all this quality and risk management, that's really a life cycle embracing thing. Because as you can see, for example, in this technical advisory part, here it comes to checking the HVAC design or to run simulations and so on. So model checks are really a very important pillar across all these life cycle stages for us. And the interesting point is that our finding is that usually projects in Asia, when it comes to the digital quality and risk management and quality items, usually it's how to say, it's an unspoken task for the BIM management. And here we see so many questions like what is checked, what's important items for BIM quality, or when a result is good, when it's bad. Also the question, how do I transmit the results to consulting building owners? So here's the question, is this blame game? Like I find errors and I, how to say, reject taking over the models. Is that really a valid game today? We believe not. So we face with the fact that especially in Asia, all this BIM management and this model checking items, they are not standardized. So it's really a problem that BIM management, there is not yet a clear definition by quality and work scope together. Also, there is the point that is the virtual construction quality really the only item for a project? We answer for ourselves, no, it's not. Or especially when it comes to IFC, are there any best practices on what is a good Revit to extract IFC, or what is a good Archicad, Alplan, and so on? So here we see the BIM management is not yet fully standardized, which is more a best guess in a project. And as well, the IFC handling would need to be improved on the industry level. It means that the industry needs some gateway, how proper native models are created to extract proper IFCs, and then how to handle IFCs as well. But the biggest problem that we see currently, we're not doing BIM projects because we want to achieve good digital models. We do projects because BIM should help to build good projects and to build good physical buildings. So in our opinion, it's never just about the BIM itself in a project. And the two major items that are really essential, much more essential than the BIM itself, mainly technical compliance and the design quality on one side, and the completeness of design, they are usually not so much taken into account. So we recognize that there is really a huge hype around the BIM in the project, but not around the design quality itself, and not about the completeness of design. And as you can see, we feel that especially these two items, they are most important, and that BIM is just the vehicle to achieve this design quality and completeness of design, right? So what's behind these two things? And let me speak a bit more in detail. So design quality or technical compliance. Here is the big question if the consultant has really carried out the design according to recognized local standards, or if not, if there are really technical improvements, mainly on performance or cost side, compared to the state of the art from the technical compliance. So here, model checks should be really utilized not only to understand is the BIM model properly modeled by VDC, but is the design quality really good? That is the major item of the model checks we have setting up. And the second item, completeness of design, we face, it's a problem across the globe in Europe as well, that most of the projects have an incomplete design by the recent stage. It means that a lot of uncompleted designs are moved to the next stage, causing a lot of RFQs and so on. And another point is that very essential things like design for maintainability, green mark, and so on, are they really taken into account or not? So this chart is maybe the most important one in this webinar, because that should really highlight that the BIM is not the most important thing, but the quality of the design and the completeness of design. That's really the most critical aspects in our model checking workflow. And to bring you some practical projects about why we so much engage on this completeness and design quality level, I brought some projects to you. So one is a sports stadium facility for a $65 million capex, and it should encounter 12,000 guests. We came on board during the fit-out phase, and here it was all modeled in different softwares. Explicitly, it was an IFC compiled by 8 different authoring tools. And the interesting thing, we find out that the fit-out design was only complete by 72%. And we found some performance errors according to Aircon, and DFM. So this check was very important for all, for the building owner, for the previous consultant, for the current consultant, because we really avoided with this fast check, which took like 10 man days, and some automatic checks. We avoided some financial harm for all the stakeholders. And that's really a cool point, because usually such big projects we would need to qualify over 2 or 3 weeks, right? But in a couple of days we could already highlight some of our findings, and we could guide the previous consultant into the right direction about what is completed, what's not completed, and so on. And another one is a residential building. It's a smaller one, so it's 3 apartment assets with 5,000 square meter GFA, like a chalet style, and that was in native Revit models, then converted into IFC. And here it was a finding that with model checks, like you can see on the right side, we find so many layout errors that are not compliant to the local standards, that really we help the consultant with a very immediate advisory about what to improve to have a design that's really compliant to local standard. And we've asked our HVAC validation officers about how long they would need for project usually, and feedback was like 2 or 3 weeks. With model checks, it can be really done within a day, and then we had some 8 man days project check to find out how sustainability and so on could be improved, and that was done with Solibri as well. So that should bring some clarity to you about the completeness of design and design quality itself. That's really major points for model checkers and so on. Here's a third one. Unfortunately, I recognize that the video doesn't play, but that's an interesting point we did for the Ministry of Social Housing in Brazil. We have been setting up their project management dedicated with Solibri, and interestingly, that was for social housing. We validated some facade items, some handicap layout items, and so on, and that saves the authority per month 900 hours. For them, that's a really great achievement, because they have more projects than they can handle, and this automated code compliance or this automated design checks really help the authority in Brazil to perform much faster and to, how to say, embrace all these big construction programs. So this I brought as examples that model checks are really not just to check the VDC quality of models, but really to work on the design level, I mean on the technical level itself. Right, so summarized for us, it's like a 3-step process. First, for sure, we need to have the BIM models checked on the virtual construction level, because like I say in the beginning, BIM models are really an essential pillar for, or the BIM model itself is an information vehicle, both for technical layers, completeness layers, and so on. So the BIM model itself needs to be very accurately designed on the VDC level. The second level is the design quality and the technical compliance. And the third one is the completeness of design. So by this, we call it really lean management or lean design and construction, because the zero error principle, that's a really very important item for IDD and DFMA as well. Yeah. So, and all the things reflect to the BIM management packages that we have been building up that may differ from everything that you usually see in Asia, because usually we face with the fact that in Asia, the BIM manager count models and the BIM manager is the instance for VDC quality. But explicitly, because of the design items like completeness and quality, we have been building up different project management offices that also take into account exactly these things. Like we're taking the Revit or the IFC models and we're checking design itself on technical level, on sustainability level, on CapEx level, and so on. So that's how we utilize the BIM model checkers as well. Right. Let me say some words about the ecosystems that we're facing with. So on one side, we have the native Revit, which has the highest Asian coverage as an authoring tool, and on the other side, we have the IFC as a desired mandatory project ecosystem. I mean, Coronet in Singapore runs on IFC and so on. So this is a very common, project setup that we see. There is a lot of Revit converted to IFC. And you can see that especially in India, Singapore, Indonesia, Malaysia, there's such high coverage in Revit that we have been even taking into account that we can check native Revit models as well. Yeah, because we really face with the fact that Autodesk Revit converts into IFC is a really common practice, especially in, like I say, especially in India and Singapore. So on that, code level, IFC, Revit, and so on, we have been thinking about advantages and challenges. So benefit of the native Revit is the highly flexible model setup with unlimited opportunities. I mean, you know that you can program shared parameter files, you have own families, own templates, and so on. And here we see that the EIR, exchange information requirement, is really the most essential part of the project, just to have, a pre-requirement for model checks. Because if you don't have an EIR, you don't know what you need to check in the model set itself, right? And interesting thing that's really different from the IFC approach. Here we have a multi-tool checking approach. So Autodesk provides multi-tools like Navisworks, Dynamo, Insight, Tele, and so on. So that requires as well that the BP and the Master Information Delivery Plan is really accurate to see who checks what, when, and how. That's really to be interpreted and to be defined for every single project. So the contrast to IFC, the IFC is much more easier to be honest. Here on the IFC level, we have a fixed scope based on this ISO standard, based on the current IFC for 0 or for X implementation stage. Yeah, so here we don't need to discuss about nomenclature, structures, and so on. That's a fixed structure of parameter sets, of geostructures, and so on. The critical item is, and that a lot of reads do wrong in Asia, if you go for IFC, don't make custom rules. So IFC is really good when it's a plain, clean, original IFC. And so here it's essential to have synchronization with all of the trades, because all trades need to fulfill the same quality, the same structure of IFC, and they don't need to try, or they would not need to try to rope in their individual model structures and so on. And based on our findings, that's why it's a contrast to the Autodesk ecosystem. So checking IFC, for us, we find out that Solibri is the best-in-class solution, because when we validate different checking tools, we see that Solibri has the most plain, the most accurate, and the most clean IFC code inside. So the interesting point, we had an Asian customer from Singapore ask, why were you using Solibri? and that with his checking tool, he get results as well. The answer from us when we checked the results was, for sure, when you have a model check, you always get a result. The problem is it accurate or not? So Solibri is really based on our opinion a best-in-class solution, and that's why we have been developing some checks, especially for this highly interesting IFC, exactly both based on this Solibri solution. And about the IFC level itself, I mean, you all know these different challenges on software level, or user author level, owner and employer level. Yeah, so IFC might look like a standard, but you all know that the different software tools have a different IFC scope implemented. On user level, there are trainings for programs, but not for the IFC itself. So IFC handling, there is no training, and we have changed that, by the way. And on owner and employee level, I already highlighted that if you really go for IFC owners from industry or REITs, don't go for the individual setup. And by the way, if you see right-hand side of your WebEx, you will see that sometimes we will pull in some questions. And here's our first good question. We would like to know from you if you ever faced with challenges dealing with this IFC project exactly on this level. So you can just pull a question, and later we will unveil this. Exactly. So that's the challenges. And now the solution, we wanted to stop, especially in Asia, this blame game about IFC. So we wanted to bring help for the industry level, saying that what is a good IFC? I mean, we have been together with Solibri developing a best practice about, and based on our management findings about what is a critical method of IFC. My colleagues, as Elise, she will take you on a journey and deep dive into this rule sets later. We also want to answer what is really critical and when is it anyway okay. So not every mistake is a no-go. Yeah. What do I need to improve? Here, that's very relevant that we as TÜV SÜD do not issue paper reports, but a BCF report that can be plugged in right into the authoring tool and so on. So to make a long story short, we wanted really to help the Asian industry and the Asian project ecosystem to deal with IFC, because IFC 4.0 has heavily improved towards the former IFC 2.3. And the check that we have been developing contains these four points. First, it's the check. It's a Solibri and TÜV SÜD joint standard. Then, based on this check, we will issue a quality and risk report where you can really see how your project is about quality and so on. Trainings, because we feel that standards and best practices, they should be trained on projects. And fourth pillar is project verification and certification, because we really see that ISO 19665 is a very, very important matter in Asia. Yeah. And the trainings itself, that's what we're going to launch in Asia. We feel that the industry level, like consultants, contractors, facility managers, and so on, they would need, or they are seeking for, an online-based training, and that's why PSP in Singapore will start an online academy exactly with these, how to say, modules. They will start easy, and we really feel that knowledge about implementation, about standards and guidelines like IFC and like model checks, they are really a very important, how to say, knowledge point. So another question is right side, if you would see an interest in BIM trainings held by international project experts, because that's what we plan. We don't plan to do trainings with academic people who have never worked with BIM models or with IFCs, but this training should be set up by our project experts like Elise or like our other colleagues as well. So here you can poll again if this is interesting for you. And now I would like to hand over to Elise, who would take you on a journey on the technical level down to the solution itself. Please.
Thanks, Tobias. Hello, I'm Elise Mandat, BIM consultant at TÜV SÜD at WIMO since 2018, and I come from the field of planning and architecture. as Michelle already introduced. I have also worked as a BIM expert in quality assurance and planning, and also in construction. Today, I'd like to introduce you to the way we examine the issues that Tobias just discussed. You're probably excited to see the model checker in action. So here you can see TÜV SÜD's Solibri dashboard, where an automatic check of the 65 essential quality and risk aspects in IFC projects is carried out. All the checks run simultaneously in selected project models, usually several instead of just one BIM model. This also means a great deal of time savings for our customers in issuing a report of the results. Our TÜV SÜD experts have defined around 65 planning errors that frequently occur in architecture, structural, and technical building equipment models. So this review focuses not only on individual planning models, like I said, but also on the correct integration of all the trade models together. So together with Solibri, we have grouped these rules into 4 main categories, and they are model structure and integrity, modeling guidelines and rules, information requirements, and geometry requirements. So as TÜV SÜD, we receive many high-quality BIM models for large projects, which is a good thing. These projects often include 10 to 15 different trade models, all in one coordination BIM model. But even if the planning is of high quality, there are often major risks that occur within these BIM models. So what can go wrong with these BIM models? And I see that we just received another polling question on your right-hand side. If you'd like to answer while I speak, how would you rate your current BIM in-house competence? So what can go wrong with these BIM models? First category, we see model structure and integrity. So these risks divided into these 4 main testing categories. Surprisingly, in model structure and integrity, the main risk concerning that is that the same building that we're talking about is defined by the trades with different world coordinates, different levels, or different degrees of detail, which makes for not the same building that we're all talking about. In addition, the components must be defined using the same naming standards so that they are universally identifiable among all trades. For this, we use the IFC standard. It is essential to check that all elements are defined according to their IFC entity. Without this consistent structure, there is a risk that the trade models will not be coordinated correctly, and it will cost much more time in BIM management. In the worst case, the models may even have to be remodeled. Second, why do we need modeling guidelines? Because this is the basis for proper BDC modeling practices and clean IFC output. Without these guidelines, BIM models are constructed differently from trade to trade, resulting in inhomogeneous IFCs. Only if the components are modeled with the same attributes with which they are also maintained later in facilities management can we track and create valuable documentation of the facilities from the very beginning of the project. So in this way, the client has a precise overview of the facility to be managed from the planning phase through operation. Thirdly, we focus on the information requirements to avoid uncoordinated information comparison between the trades. This often occurs when the trades do not match the attributes and formats thereof in their models. It often happens that the trades have this information in their models, but each trade in its own format or with its own attribute nomenclature. This is one of the most hidden risks because it goes unnoticed until a BIM manager checks that all trades use the same attributes throughout. So an uncoordinated exchange of information like this leads to misinterpretation, duplication, and the possibility of trusting false information. So this is often only recognized when the information is imported into a CAFM system for facilities management, when it is then too late. The last, perhaps the simplest category of control is geometric requirements. This is the classic collision detection, where we want to detect and avoid collisions between different models at an early stage. Without these requirements, there's a risk that clashes will remain undetected until they incur change orders on the construction site, which no one wants. In addition to this, this is the basis for a precise quantity takeoff. So for us, complete transparency behind the result is important. Here you can see the detailed protocol with all results and an analysis of the 4 main test categories that we produce. In this way, we validate positive issues with the modeling, whereby, of course, we also highlight risks and opportunities, of course, for optimization. From this report, we derive 4 risk classifications for you according to the ISO 31000 international standard. These risk classifications show you how your project is currently performing. C1 is the highest risk because the BIM model lacks all data. C4 means the lowest risk. As there is never a project in ISO 31000 where there is no risk, our customers often translate this level as everything in the green zone. Here are some examples of graphics that we create for you as a part of the report. For both clients and contractors, it is important that a TÜV SÜD export is available after the model check to explain the results. We don't want you to go at it alone and just look at this report and wonder what it's talking about. Since a pure report isn't sufficient to explain issues for complex construction projects with BIM, we combine the model check and the quality index as a report with accessibility directly to our team. In this way, we ensure that we really integrate best practices into your project, that we do it along with you. So what is the delivery of our check? We have 3 different parts of the deliverable. The first is the quality check and index report. This is for owners. It is a basic translation of the issues in the form of a benchmark. The second is a detailed report and BCS report of the issues. This is a technical report for consultants and contractors. It is a deeper dive to understand the reported issues found by the model checker. And thirdly, we have a technical compliance check, what is traditionally known as design review. This is for highly complex or risky projects, which we offer on top of the basic IFC checks. Here I will take you through 10 or so concrete examples of checks that the model checker performs. One of the strongest benefits of the IFC checker is that it gives us the ability at any point in the project to very quickly see what's going on. No more wondering how the trades are coordinating, what information is missing, what elements are duplicated, or what systems are incomplete. Here with the click of a button, actually, it's true, we see the intersections of all components in the MEP domain that are clashing. I could just as easily perform the same check for architecture, structural, or even a different check to review the completeness of information. We can also quickly identify duplicated elements. What can the major issue be when elements are duplicated? It can lead to faulty quantity takeoff, where elements are counted twice. Or it can lead to incorrect planning when an element is updated by one trade and not by the other. Which element then do we trust to be correct? This leads to confusion and, at worst, the necessity for remodeling. In the same way, we use the model checker to monitor a clean and perfect room program is kept throughout the project. To which room do objects belong? This is important all the way from planning through construction and into facilities management. We also perform fundamental coordination checks, such as if the project base point and rotation to true north is exactly the same for all trades. As we see in this example, it is not. If this is not correct, the project cannot proceed, because then we do not have coordinated models. We're not talking about the same building. The model checker can verify actual material thicknesses. Previously, with paper planning, material quantities were always defined apart from the planned object itself. Here, we truly harmonize the planned object with the amount of material that is called for. In this example, we see the definition of the material is 90 millimeters, but in fact, its information definition states 0 millimeters. This will lead to incorrect quantity takeoff. We also check whether every element is defined by type, thus correctly categorizing it in relation to all other elements. In BIM, we must make sure that we are modeling in a way that the computer understands. And the first step to this is defining all elements by their most general category. This coincides with each element's IFC definition as well, which categorizes it in relation to its IFC entity definition. Often we find that elements are modeled with the definition IFC proxy element, which basically means the modeler forgot to define the element's category. If this remains so vague throughout the project, the elements will be missed in clash detection, quantity takeoff, and will not be properly defined in the facilities management system when the building is finished. This is a fundamental check that can lead to many problems if left unchecked. Here, we are checking for too much detail. For example, we see here the texture on the door and the lettering on the equipment. Each line drawn in the authoring software adds to the size of the file. So when objects, especially those that come directly from a manufacturer, you download it off their website, contains a lot of detail and oftentimes much too much detail, which slows performance and causes anyone working in the model to lose time. This can be many man-hours if it's added up. Here we are checking that the levels defined are those that are used unanimously by all trades. We have found here that there are empty levels, meaning some trades have defined their own levels. In this case, it is not to the point where building objects have been referenced to the ununified levels. But in this check, we would flag the issue and recommend that the empty levels be deleted to avoid that very risk. So I have just seen that we have another question pop up in our polling area. Are you interested in discussing your IFC project with experts? So I hope I was able to show you the use of the model checker by means of the whole project examples. The application of the model checker is endless. We can program many, many things into it. But after all, it is a matter of definition of what checks you want to perform with them and how the results are used by the BIM manager to control the information right from the start of the project. And in this checker, we have defined the 65 essential IFC checks that we have deemed the most essential to perform at the beginning of your project. So, are you interested in having your IFC project checked? Do you suppose your BIM models could have some of the above issues that I just mentioned? Would you like to know any of the possible risks before your project goes any further? Here at TÜV SÜD, we have a 5-year BIM management best practices that are tried and true, built from a common IFC checking standard and powered, in this case, by Solibri software to facilitate these essential checks. This model checker will train the industry how to properly implement IFC in projects because it can be used on the job. Owners, contractors, architects, modelers, they can all access it and perform checks at any time. This could easily help guide your team as well to maintain one guiding standard among many stakeholders and many models.
Great. Thanks, Elise, for this technical insight. So from our technical point, I hope that this 40 minutes journey through our findings on project level when it comes to quality and risk management and this journey into our model check itself was exciting for you. Probably you gained some more interesting aspects you can integrate in your next projects. If you would like to have your IFC project check, just post as an email to Gilbert Lau, to Elise, or to myself. And we also have the BIM pages where you can inform about BIM advisory, BIM management, BIM to CAFM, and so on. Because, like we say, model checks are relevant on all these 3 stages. So we hope you enjoy, and I think the colleagues would like to start a Q&A session now.
Okay, so thank you, Elise and Tobias, for your time. We hope all of you find this session interesting and relevant. If you still have any burning questions, please feel free to send us an email, and our BIM expert will take some time to actually answer your question.
Great. Thanks a lot from our side, and have a good afternoon to Singapore, Malaysia, India, Philippines. I hope I didn't forget the country that's participating, so thanks a lot from our side.
Yes, thank you so much. It's been a pleasure.
So thank you everyone for joining us today. Let us know what you think about the webinar by filling out the survey form, and have a good rest of the day ahead.
Thank you.
Bye-bye.
Bye.